notice the labels aren't sorting and the data still isn't working right. So we need to fix that. So we're going to add to the sort chart function. We're going to here's where we're going to select all the rectangles, and this each function basically executes for each of the data elements, and it'll push the key value into the new domain. So that's, remember how I set up that empty array. So now we're going to set up the new domain. And then I'm going to pass that domain into my X scale. So I remember how I set up my X scale before. Now I'm going to change it. I'm going to say, all right, now this is the new domain. And then I'm going to add a transition with the duration, and I'm going to recall the x-axis. And that is going to rebuild my axis based on this new domain. And I have to reset this style because I found that if I didn't do that, the placement of the labels kind of went out of whack. So I don't know if that was a bug or not, but I had to do it. And I also added a delay to the transition. And what that does is it waits for an amount of time before it actually does the transition. So I set it to be I, which is the index, times 50 milliseconds. So the first one's going to do is going to go instantaneously, and the other ones are going to follow. And a way, if you have a lot of data and you don't want to kind of wait for all the data to sort, another way to sort of normalize the total duration of a staggered transition is to do something like this, where you take I divided by data set length times 1,000. So at the last data element, the most delay you're going to have is 1 second, and then everything else is going to be normalized before that. So here's how that looks like. And because we changed the because we changed the domain of the X scale, that also fixes the label positioning, because that's based on your X scale. And just to add a little bit more, what I did is on sorting, I changed the color to be a shade of blue that reflects the data. So RGB values go from 0 to 255, so our B value is blue, and if I take D value divided by the max value, so for the max value you're going to get 255, and for everything else you get something below that. So this is what you get. So now you have a sortable chart that, I mean, it's not the most eye-popping visualization, but kind of shows some of the concepts. So in summary, we obtain the data in JS format, create the parent SVG element. We configure the SVG elements that make up our chart. We configure our scale functions to normalize our values to our output. And then we use our scales to set up our axes. Then we can change the underlying data. So in this example, we sorted the data, and then we update the chart to reflect the data update, and then we added transitions to kind of sort of sweeten the visual aspect of the transformation. All right, any questions up till now?
So if you were to view this on an iPad mobile device, if I could then do the right thing,
Will it work on a mobile device? Is that what you're asking?
yeah, that putting on like in terms of
Yeah. Yep. Because most, especially an iPad, it's got a modern browser, so it'll handle that CG fine. So.
But somehow do they just each canvas elements? Do they factor to D3 at all?
So D3 uses SVG, but SVG is very similar to Canvas, right? So Canvas works in a similar way. There's another library called Vega, I think, that can use for visualization that uses Canvas. So if you're more comfortable with Canvas, I think you might want to look into that. Yeah. I won't use it. All right, so layouts are functions that basically take your data, transform it, and add sort of other data to it to make it easy for you to output specialized visualization. So pie charts, board charts, bundle. D2's got a lot of them. So this I'll show an example of a pie layout. So again, we defined the dimensions. We give it an outer radius and an inner radius. And the inner radius, if we give it a value, it'll be this sort of a donut chart. So the arc function helps us draw our SVG paths. So a pie is made up of paths, basically. So we call the SVG arc, and again here we're setting up a variable that holds a function, and we're configuring it here. So it'll be SVG arc, and we have to pass in inner radius and outer radius, which we already set up here. And then here I'm just generating some random data. D3 range 6 will just give me a simple array with the number, this many elements, so the number 0 to 5. And I'll map a random number between 0 and 50. So here, if I output the data set, it's just random numbers, right? But when I set up this pi function, what it'll do is it'll take this data, and if I call pi on it, it'll add all this other information to it. And D3 uses information to create your paths for your visualization, your pi. So again, now we define an SVG element, we give it a width and a height, and then we set up this this color scale. So this is a special kind of scale that gives you 10 colors for categories. I'm not sure if they kind of researched the color blindness thing or anything like that, but it gives you 10 colors. All right, so you set up your wedges as group elements. So again, you pass in your data, your pi eyes data. So you call the pi function on it, and then for each datum, you append another group element, give it a class wedge, and you have to translate each wedge into the center of the pi. So you just pass in the outer and inner radius. And then to each wedge, you append a path. And you fill it using this color scale. So it'll just kind of give you whatever color comes out. And D is the attribute of a path that describes the appearance. And what you pass in for D is that arc function that we set up over here. Right? So you don't have to really worry about what you have to pass, where you pass in from D. Right? So here's our pi. And if I inspect element in one of these wedges, you can see sort of what that arc function does to you. Here's D. So it generates all this code for you, so you don't have to really worry about it. And then to give it some.
Is pi a D3 function or the?
Huh?
Is pi a D3 function?
Yep. Yep.
Because you only get pi directly on D3.
Yeah, you set it up and then you call pi on your data, and that's what you use to pass in. So for your labels, you can use this this centroid function from the arc that you already set up. If you call centroid, what it'll do is it'll calculate the center point, any irregular size shape. So you can position your label into the centroid, and then you return the value, right? So there's your pi, and then I added this animation where you can update your pi. Now, a couple of things to notice here is, first of all, see how it's bouncing? So that's another attribute you can pass into a transition, is an easing function. The default is linear, but you can pass in bounce, and I'll show you how that is. And the reason why, you see how it's changing the order of the colors? And the reason why it's doing that is if you notice, it goes from 6, 27, 32, 44, 48, 48. And it's always going to sort them. It's always going to sort these wedges by the value, and that's the default behavior. But it kind of makes for sort of a jarring animation. So you can turn off sorting by when you, well, first of all, let me go into these animations here. So basically, I wrapped the the code that generates the data into a function, and I added an event handler to that button, so that new data is generated, and then I pass in new data into this, I pass it into the Pi function, which is in turn passed into the data function. And then here's where I do the bounce easing. And then I redraw my wedges again, right? And I do the same thing with the levels. But you can get it to not sort the values if when you set up your Pi function, you call sort null. If you do sort null, you get sort of null. And I turned off the bounce on this one. It was just more to kind of show it's a little bit gratuitous. So there's an example of a layout.
Should rename that the beach ball.
All right, here's some resources for sort of, there's tons of resources out there, but here's some for beginners, d3js.org or d3js.com has a tutorial that you can go through, and it's got this newsletter that you can sign up for that's got a lot of interesting articles that can be sent to your mailbox. d3noob.org has a lot of tips and tricks for D3. And then there's this tech slide that has over 1,000 samples of D3JS visualizations, and they all have code.
I think someone should make a data visualization to make it simpler to look at D3.
So yeah, there's plenty of stuff here to look at. And there's this book that just came out in March, Interactive Data Visualization for the Web by Scott Murray. That's really good. I read it. It's not a very long read, and it actually has a chapter that kind of gives you all you need to know about HTML, CSS, and JavaScript for those who don't have that experience. And it's really highly recommended. It's got a really good style to it. That would kind of get you up and running. That's it. Any questions?
So it's nice that you get this level of control over
Yeah.
everything. But that's also the bad news, right?
Right.
I mean, it's,
Yeah.
so in some sense, I'm looking for something that's more like ggplot2,
Right.
Higher level.
So a good segue, because we have a guest person in the audience tonight who created a package that ties R together with D3. And he's going to speak here shortly and present. I mentioned when I did the intro how there's all these new R packages that bridge D3 to R. One is called ClickMe, another one is called HealthViz, and another one is called R Charts.
So actually, just one thing I want to say is
Yeah.
there's also this library that just came out where they're building reusable components built on D3. So yeah, I agree. D3 is very low level, right? So it's not like a charting library. You can't just throw data at D3 and it'll spit out stuff. But these guys are sort of working towards sort of building on top of D3 and sort of abstracting out all that lower level stuff and giving you sort of reusable charts built on top of D3. So I kind of suggest this is something you can look at too, NVD3JS.
That's what I was asking about.
Yeah.
I was looking for something comparable to ggplot,
Yeah,
but something that's more
Right.
D3.
yeah, and I think this allows you to kind of also, it gives you that sort of abstract level D3, and then allows you to kind of dig and kind of tweak it to your liking.
So Nacho's going to show what he's created. I'll let you take it from here.
Thanks for the solution. Hi guys, my name is Nacho Caballero, and I saw that 45% of the people that came said that they use R as their main tool for visualization. And after you build your first D3 visualization using the tips that Tony and Gary have given you, so it takes a lot of time, especially at the beginning, to build D3 stuff, D3 visualizations. And then once you learn how to do it, it takes even more time because you want to add even more interactivity and more features. So as you're increasing the amount of time that you're investing to build your visualizations, you want to make them reusable. R is great to work with your data, shape it so it has the format that you want it to have, but it doesn't do interactivity very well. That's why we use JavaScript. So I created an R package that makes the transition between JavaScript, D3 or any other library and R much easier. The code is available on GitHub, and so you just go to github/nachocab/clickme, or just this URL, bit.ly/clickme, or clickme wiki if you want to see the wiki. You can, so actually, okay, this is actually better. The only thing you need to install it is to run this code in R. So I'm gonna go through a quick demo, and then if you have any questions or along the way, feel free to ask them. So, okay, it's been a while since I used this because I took a little break to prepare for my qualifying exam. So the best way to figure out how it works is to run a demo. So I'm going to run a parallel coordinates plot. It's showing me what code is going to run. So I just hit enter, and it opens up a browser. So this looks okay. So you've seen it before. John showed you. This is interactive. You can select what cars have this displacement, but have an economy of whatever. Well, you don't get anyway. So the input is coming from R, and you saw that that was the code that was running. The cars is just a data frame, and you can see that each axis is representing one of the columns in the data frame. So I can change, I can input any matrix or any data frame that I want to use, and it will display it using the visualization that somebody else created. You can actually customize this, and instead of, right now I'm coloring by cylinders, but we could change it, so this is done in R. So now I say I want to color by power, and change the height so I can actually see, so it's a bit smaller. Right, so now the power, no, what was it? Yeah, the power. Now it's coloring by the power. So this is red and this is blue, as opposed to the previous one. So let me show you another example.
So how did you do this? Just like, when you came with the idea, it just, so you broke all the, the D3 stuff kind of in the.
I took D3 stuff that started with what Mike Bostock did. I took, actually, let me show you that one. That looks pretty. If you've worked with D3, you're familiar with this type of data. It's a network diagram, and it's interactive. And I wanted to visualize my data using this. So I'm going to show you the guts behind it, and I have a very detailed wiki that you can go step by step. And you can take whatever visualization that you want and make it accessible from R. So I'll just show you what I did on this one. Let me get this stuff out of the way. So I call them reactives. Instead of the traditional visualization, it's an interactive visualization, R. And it has three major components. The template, which you should be familiar with, it's just the HTML file that is rendered by the browser. It just has additional stuff that is interpreted by R, like this one, for example. The double brackets is just a way for R to know that it has to replace that the stuff between the double brackets with a variable in R. In this case, the title. The main function is the data. So if you, all right, let's do that. Let's look at the source code, and you can see that the variable links has all the data. This data that you see, gene, target, source, type, that is in the data frame. Okay, so this corresponds to what you're seeing here. It's just that the format is different because in R you have a data frame, and the browser doesn't want a data frame, it wants a JSON object, which is this. So thanks to this double brackets that we have here, it gets converted behind the scenes and you don't have to worry about it. Once you set it up, you never have to worry about it again. So that's one part. The other part is the translator, and that's all I have here. It's I'm just calling a function that translates the data frame into a JSON object on a specific format. It's actually not, so there are many libraries that you can call. Here I'm calling the data frame to JSON. There are others. You might want something different depending on the visualization, because each visualization is going to expect a different input, or there will be main categories of different inputs, but you can potentially just want an array instead of a JSON object. And then the last component is the config, the configuration. And here I'm just specifying the names that the data frame should have. So for example, if your names are not correct, if you have a data frame that has 3 columns, but instead of source, target, and type, it's called A, B, and C, you can actually map the names so you don't have to rename it. And ClickMe does this stuff on the backside. Does the conversion on the backside. Here's just some default values for the width, the title. So I put force directed, and that's what you see. That's what you see here. And I downloaded the dependencies. The D3 code is actually stored in this folder, the external folder, and the same thing for the CSS. So this ties up very nicely with what you explained before. The last key point is the requirement server. Some visualizations don't expect a direct variable, they expect a file. And because of some security restrictions that modern browsers have, you cannot access the local file system from the browser, so you need to run a local server. But to do that, the only thing you have to do is just go to this shell and run. I have it set up so it's running a. Let me show you. Oh well. So the only thing I'm calling is, I think it's Python minus n, because server is an alias that I was using, and then simple HTTP server. I think that's all you need to run. But just go online and search for how to run a local server, and what that does is that instead of seeing the file here, this just means this URL just represents an HTML file that has been created in your system, and it's opening it directly. And I think for this other visualization, it also generates the HTML file that is sitting in your system, but it's not opening it directly, it's opening it through the server. That's why it has localhost 8000 here. So that's just a minor detail. But the goal of doing all this is making your D3, giving another life to your visualization, so you don't have to edit the code manually and change the data source, so you can do it from R. So I'll be happy to take any questions if you have them. And just my last point is that if you want to learn more, I spent a lot of time writing the wiki. For developers, it's a pain, but actually, if anybody is struggling with documentation, all the time that I invested on writing the wiki actually serves you first. Because as you write, you realize that some stuff that, if it's hard to explain, you probably have to change it. It's probably badly implemented. So it helped me a lot to improve my code. I have a quick guide for people that know what they're doing because they've done it before, and a slow guide with very detailed steps on how to go about everything. So I recommend, if you want to check it out, just go GitHub, click me, or you'll find it. So you had a question?
Yeah, so good job
Thanks.
setting it up and so on. So the question I had was, obviously D3 runs in a browser
Right.
most of the time. And so what assumptions do you make about R being available to the, to the Joe Schmo out there who's running my visualization? How
Oh.
do I connect to it?
So you as the person that's creating the visualization, you're using ClickMe to generate it. But the person that you could potentially put in your server, and another person could look at it, but they don't need to know that you use R to generate it.
Right, okay.
Right? So there's no R dependency for the user, for the casual user. You have R because that's where your data lives.
So you can take the JavaScript output
Right.
and just.
You're actually, okay, so let me show you that.
So you don't need to run R on your remote server?
You cannot.
Okay.
You cannot.
You're
So I mean,
running
we did
a-
this.
You're running a local server to do your own
Yeah,
stuff.
do your own
That
stuff.
could just
Yeah.
as well be
Right.
a public server.
Right. You could.
Right, yeah, I know.
At that point, I guess, so if you like Shiny, if you know about Shiny, I haven't used Shiny that much because mainly I just run stuff locally. But actually, there are other libraries as well besides ClickMe. You mentioned RCharts and HealthBiz. They both provide ways to share when you have your visualization. It's finished, an easier way to publish it. If that's what you need, check them out. But at the end of the day, when you run the ClickMe function, you're generating an HTML file. This is what you generated. This is what was being rendered. So if it's an HTML file, you only need to put it in your server if you want to share it, or email it to somebody. Like you can email this particular file. You can email it to somebody, and they can just double click it, open in the browser, and see the whole thing.
So the stuff that Tony showed with MPG3 you can buy with ClickMe.
Right. So for example, I have this line with focus uses an MVD3, the MVD3 library. So not only D3 or MVD3, any JavaScript that you want, as long as you change the template. So let me show you the template here. This is an MVD3 object, and I'm doing the same thing. I'm just replacing. I found it somewhere on the web. Okay, let me show you what it looks like. So. I found this graph and I liked it, and I just went, view page source. I downloaded the source, and then I saw where the data was being stored. This was actually kind of complicated because they were using a function to generate mock data for this stuff. But if you go to the MVD3 website and you see a demo that you like, you can totally do this. You just go, download the code, and then see where the data is being generated. In this case, the data is being stored here, this variable. So I just replaced it with this, and then this function is defined in the translator. And then I added an additional function because it needs a very convoluted nested structure. But that always depends on the visualization. Like maybe they want an array of hashes or a hash of arrays. Or you are gonna have to know something about JavaScript to reverse engineer it.